siyang negative ion. Okay, na naman. So, kung ako na ni siya, ang isa ka, mahimo na ni siyang NH2. Mahimo na siyang NH2. Kaya nga naman, ang positive is now taken by NaOH. NaOH. So, ang nabilin, negative charge. So, mahimo na siyang negatively charged. Okay? Are you with me? Now, you can observe this in when you will be having your laboratory. Okay? Dealing with our properties of, say, amino acids. Again, if you will place our amino acid in water, then its charge, or say its structure, is in the form of Zweiter ion. There is positive charge and there is negative charge. But if you will add acid in such a way, like for example the hydrochloric acid, in such a way that the pH goes to 2.0 or lower than 2.0, very acidic. So the acid or the proton of the acid is donated to the carboxyl group in such a way that the charge, the overall charge of the amino acid is positive 1. Okay? So it becomes positive 1. Now, if a strong base is added, the tendency there, the proton in the amino group is taken by the base, by the sodium hydroxide, in such a way that what is left now is the carboxyl group charge. So the charge of our, of our amino acid is negative 1. Okay? So, if acid is added in an amino acid, then the charge is positive 1. If the charge, if a base is added, then the charge of our amino acid becomes negative. Okay, negative. It becomes negative ion. Okay? So, any question here? So, like this, to summarize, we have, when will this happen? Ang net charge is Zweiter ion. This one, if there is acidic substance that will be added, highly acidic, so ang amino acid becomes positive charge, positively charged. If a strong base is added, the overall charge of our amino acid is negative charge, negative 1. Okay? So take note of this. Now we have this isoelectric point in which the majority of molecules of a compound in solution have no net charge. No net charge. Now you'll be using this in your laboratory later. We'll be dealing this. You will look for or determine the isoelectric point of the different amino acids. Yeah. So for the acidic, we have here kani basic, kani usually almost neutral. So when we say isoelectric point, now this is the point class where majority of the molecules in a solution have no net charge. Wala siya net charge. Not positive, not negative. Kanus A. Now, just like for example, ang valine, kanus A siya nga. Wala siya net charge. That is kung yung pH is 5.97. That is isoelectric point niya. So again, when you say isoelectric point, that is the point in which the compound have no net charge. So, neither positive or neither negative. No net charge. That is what we call as isoelectric point. So, for aspartic acid, 2.77. What is this PI, isoelectric point? Okay. So, any question? Cysteine. Now, we have here SH is sulfhydryl. Sulfhydryl group of cysteine is easily oxidized to an disulfide. Say di means two. Duha ka sulfur groups. Two sulfur groups bounded together. Okay. So you have here by a disulfide bond. So if there is only one sulfur present, so we have here cysteine. This one, when there are two sulfur present, bonded together by a disulfide bond, then we have cysteine. Wala na kuan. I'm not really sure how to pronounce it, but there's a difference. Okay, this one is cysteine. This one is cysteine.
Cysteine ang Picasso.
Cysteine. Okay. So here we only have one sulfur. This one, two sulfur groups bounded together by disulfide bond.
Oxidation.
Cysteine. When we say hydroxylation, that is oxidation. Oxidation of proline, lysine, and tyrosine. Iodination for tyrosine, meaning with addition of iodine. That gives non-standard amino acids. So when you add up to specific amino acids with, say, iodine, that is through iodination, so it's no longer in standard form. This is no longer a standard form of our tyrosine. Then hydroxylation. So while proline, lysine, and tyrosine would be oxidized, then it would no longer be in its standard form. Okay. Okay. So you have here Emil Fischer again, 1902, that proposed that proteins like carbohydrates are long chains of amino acids joined by amide bonds. Now, what are these specific bonds present in amino acids? These are what we call as the peptide bond. Now, the special name given to the amide bond between the alpha carboxyl group of one amino acid and the alpha amino group of another amino acid. Now, like this is dipeptide, meaning there are two amino acids bonded together by a peptide bond. Now, you have here, say, alanine and serine bonded together by a peptide bond. Now, where is now the site of the peptide bond? For the first amino acid, iyang site is in the carboxyl group. On the second amino acid, the site of the peptide bond is in the amino group. So carboxyl of the first amino acid and on the amino group of the second amino acid. That's where the peptide bond exists. So this one, that one. So this is now the peptide bond. So this is one amino acid, this is another amino acid. This is alanine, and this is serine. Okay? And this is how the bond, the peptide bond exists. carboxyl group of the first amino acid in between the carboxyl group of the first amino acid and the amino group of the second amino acid. So these are the different peptides. The short polymer of amino acids joined by peptide bonds, classified by the number of amino acids in the chain. Di, meaning there are two amino acids joined by a peptide bond. So we call that as dipeptide. So two amino acids, one peptide bond is called dipeptide. Okay, tripeptide molecule containing 3 amino acids. So tulunan. It's easy. So it's easy to identify. Say the name is now the name of this this one reflects the number of amino acids bonded together by peptide bond. Tripeptide, 3 amino acids. Poly means several. Several amino acids bonded together by peptide bonds. Now, polypeptide is non-functional protein yet. This is immature protein. Now, when RNAs are translated into proteins, now they will not become protein right away. They are in a polypeptide form, meaning they are not yet functional. So there is what we call as process of maturation of an immature polypeptide.